Okay. Hello students. So my name is Adarsh Pai. So I will be handling your subject, that is paper number 4, corporate accounts and financial management in CS executive. Okay. So first we will be handling the subject financial management. In financial management we will be learning with regard to time value of money. Time value of money, like we say what are ABC analysis, that is what is the A graded chapter, what is the B graded chapter, and what is the C graded chapter. So literally it is a C graded, and weightage of this lesson is approximately 0 to 5 marks. But this lesson is very important because usage of this lesson comes in capital budgeting. Along with that it comes in dividend decisions and working capital management. So what are we going to learn in this lesson? So first we will be learning what is present value. Second we will be learning future value. This present value we can also indicate as PV. This is FV. Okay. Then we will be learning simple and compound interest. So basically it is nothing but calculation of interest. Okay. And then we will be learning present value of cash, present value of cash inflows. Okay, that is nothing but PVCI, and present value of cash outflows, that is PVCO. Okay, after that we will be learning about compounding effect along with durations. Yes. So this much we will be learning in time value of money. So in this video I will be only providing just basics of time value of money along with some examples. In next video we will be handling the sums. So in around 10 to 12 sums will be there in total and nothing more than that. Make sure that your basics are strong with regard to this lesson. Okay. So what exactly is time value of money? We will be learning about money and nothing else. So there is literally a concept of appreciation of money and depreciation of money. Appreciation of money is nothing but if you have some money, you are investing it somewhere, which will literally lead to increase of money. That is nothing but appreciation. What is depreciation of money? If you have money and you have not invested it in anywhere, so literally you have 1 lakh, you are just keeping that 1 lakh and not invested it anywhere. So whatever the value of money is, it is still okay. So no investment. So whatever the value of 1 lakh is, after 20 or 30 years, value will be still 1 lakh only. If you are investing it, you might get some return. Okay. So let's start with a simple example. Okay. With regard to gold, it is only just an example and nothing else. So in 1990, let's assume that value of gold is 3000 rupees per gram. Yes. In 2025, let's assume value of gold is rupees 15,000 per gram. Okay. So let's assume in 1990 I have rupees 1 lakhs. Yeah. So I have invested it in gold. So in 1990, what will be the amount of gold that I will be having? Basically, how many grams? That is nothing but rupees 1 lakhs all divided by value per gram. That is nothing but 3000 rupees per gram. Okay. So how many grams I would be having? That is nothing but 1 lakh divided by 3000. So 33.33 grams I would be having in total grams of gold. Okay. So in 2025, what is the value of gold that I would be having? So in 2025, value per gram is 15,000. How many grams of gold I have? 33.33. What will be the value of gold? 33.33 grams into rupees 15,000 per gram. So 33.33 into 15,000. So which would amount to 4,99,950. So let's take it as approx 5 lakhs. Yeah. So difference between rupees 5 lakhs minus 1 lakh is 4 lakhs. Yes. This is with regard to appreciation of money. Appreciation of rupees. Yes. So since I have invested in gold, so it will lead to increase. So my money has increased from 1990 to 2025. In 1990 I had 1 lakh, I invested it in gold. Total gold is 33.33, that is 1 lakh divided by 3000. In 2025, what is the value of gold that I will be having? That is 33.33 grams in total into 15,000 rupees per gram, which will be approximately 5 lakhs. The difference between 5 lakh minus 1 lakh, it is 4 lakhs, which will lead to appreciation of rupee. So since I have invested it, it will lead to increase in money. That is appreciation. Okay. So next, so let's consider again. I have rupees 1 lakhs. That is today. Okay, today I have 1 lakh rupees. So today, in terms of financial management, we also say it as year 0. Okay, year 0 is today. So in year 0, I have rupees 1 lakh. So after a period of 1 year, we say year 1. After a period of 2 years, we say year 2. That is nothing but year 1 ending, year 2 ending, year 3 ending. So in year 0, I have rupees 1 lakh. Okay. Let's assume I want to buy rice. So value per kg is nothing but 100 rupees per kg. What is the quantity of rice that I can buy? There is nothing but rupees 1 lakh whole divided by 100 per kg. So 1 lakh divided by 100, that is nothing but 1000 kgs of rice I can buy. Yes. In year 1, let's assume again I have 1 lakh. Year 1 is, that is nothing but end of year 1. So let's assume value of rice has increased. So 200 per kg. What is the amount of rice I can buy? 1 lakh divided by 200, which would amount to 500 kgs I can buy. So how did we arrive at 500? 1 lakh divided by 200 per kg. Yes, agree? Let's take year 2. Again I have only 1 lakh. Yes, let's assume rice value has increased to 3,300 per kg. Sorry, rupees 300 per kg. What is the quantity of rice I will be having? 1 lakh divided by 300, which would be approximately 333 kgs. How did I arrive? 1 lakh whole divided by 300 per kg. Yes, in year 3. Okay, again I have rupees 1 lakhs. Yes. Let's assume value of rice has increased to rupees 400 per kg. What is the quantity of rice I will be having? 1 lakh divided by 400, which would amount to 250 kg. That is quantity of rice that I will be having. So rupees 1 lakhs whole divided by 400 per kg. Yes. So in before example, what we had learned in with regard to gold, I had 1 lakh, I had invested in somewhere. Here I had 1 lakh today, I didn't do anything with that money. So in all the years I had only 1 lakhs. Okay. So rice per kg is increasing. Okay, which will lead to decrease in quantity that I will be having. 1,500, 333 and 250. So if money I have not invested it anywhere, it will literally lead to depreciation of money. Depreciation of money in what case? So 1 lakh I had. In the first year I could have bought 1000 kgs. Yes, same 1 lakh money I had in end of year 1. So I could have bought only 500 kgs. At the end of year 2, I had again had only 1 lakhs. I could have bought only 333 kgs. At the end of year 3, I could have bought only 250 kgs. If money is not invested anywhere, it will lead to depreciation of money. Yes, this is basic understanding and nothing else. Okay. So next. Okay. So we are done with simple, just like an introduction of time value of money. So what exactly is present value and future value? We are going to learn together. Okay, that is nothing but PV and FP. Yes. So let's take one more simple example. So I have rupees 1 lakhs. Okay, 1 lakh is simple to calculate. That's why I am using the same factor. So rupees 1 lakh, I have kept it in FD. Yes, I am getting, let's assume, 10% interest. Okay, so in this example only, let's learn present value, future value, simple interest, compound interest, everything. Yes. So there are literally two concepts. One is nothing but simple interest, another one is compound interest. Yes. With regard to simple interest, so let's assume 1 lakh FD at 10% per interest for a period of 3 years. Okay. So year 1. So 1 lakh I had today. So 1 lakh is nothing but year 0. Okay. So year 1 is nothing but end of year 1. So year 1. What is the amount of interest that I would be having? 1 lakh into 10% into 1 year, which would amount to 10,000. At the end of year 2, how much I would be having? 1 lakh into 10%. Again I had only 1 year. So 10,000. From year 1 to year 2. So 1 year. So in year 3, again 1 lakh into 10% into 1, which would amount to 10,000. So total how much interest? 30,000. Yes. What is the value of FD? 1 lakhs. Yes. At the end of year 3, what is the value of FD that I would be having? 1 lakh 30,000. That is nothing but 1 lakh plus 30,000. Yes, this is nothing but simple interest. Okay, so let's use it with compounding. So say 1 lakh I had 10% FD interest along with that for a period of 3 years. So at the end of year 1, okay, how does compounding interest work? So in our practical life, so if we are investing 1 lakh, at the end of 1 year I would be getting 10% interest, that is nothing but 10,000. So what will be the value of FD? 1 lakh plus 10,000, which would amount to 1 lakh 10,000. At the end of year 2, I will be getting interest on 1 lakh 10,000. In this example, every time I used to get interest only on 1 lakh only. In compounding interest, at the end of year 2, I will be getting 1 lakh 10,000 into 10%. At the end of year 3, whatever the value is, 1 lakh 21,000 into 10%. So year 1, 1 lakh. On that, I will be getting 10% interest. Yes, so total value would amount to 1 lakh 10,000. Agree? At the end of year 2, I will be having 1 lakh 10,000. On that, I will be getting 10% interest. So 1 lakh 10,000 plus 11,000, which would amount to 1 lakh 21,000. At the end of year 3, I will be getting 1 lakh 21,000, add 1 lakh 21,000 into 10%. So which will be amounting to 1 lakh 21,000, add by 10%. So 1 lakh 33,100. So value of FD at the end of year 3 is 1 lakh 33,100. So whatever the difference of rupees 3,100, This is due to compounding. Yes. So compounding is literally better. So in this example we can also say that this 1,30,000 is nothing but our future value. This 1 lakh is our present value. Yes, in this case also 1,33,300, 1,33,100 is future value and 1 lakh is our present value. So in both the examples we can say that future value is always greater than that of present value. Okay. So anybody having doubts in this? Okay. Just make sure you are watching it at normal speed. Maximum you can do up to 1.25 or 1.3. Don't make it at 2 or about 2 if the option is available. Okay. It might lead to certain circumstances which you might not understand the topic only. Okay. So what kind of calculations I had? So I had future value 1,33,000, 1,30,000 in the case of simple interest. Yes. 1,30,000 and present value 1 lakhs. Yes. In compound interest I had future value rupees 1,33,100 and present value rupees 1 lakhs. Yes. So in the given case, so I can just say that whatever the amount of interest was 30,000 in the first case. So I can say that interest is nothing but future value minus present value. So 1,30,000 minus 1 lakh, which is nothing but rupees 30,000. Agree? Yes. Next, in this case, interest is nothing but 1,33,100 future value minus present value. Nothing but rupees 33,100. Agree? Yes. So interest is nothing but future value minus present value. So in these cases, we literally have some formulas, okay, with regard to how to calculate future value. In before example, we had already calculated future value. So let's consider that same example and arrive at the formula. Okay. So same again, simple interest and compound interest. Here I had future value 1,30,000 and present value 1 lakh. Yes. Along with that, I had 10% interest for a period of 3 years. So can I say that future value is nothing but present value plus present value into this 10% we say it as R and 3 years we will say it as N. N is nothing but number of years. So present value into R into N. Agree? So what is the value? Future value 1,30,000. Yes. What is the value? Present value 1 lakhs plus 1 lakh into 10% into 3 years. Agree? So I will be getting 30,000, which will ultimately lead to 1,30,000. So let's consider this 1,30,000 is equal to, let's take 1 lakh common. So 1 lakh is common. So I took 1 lakh out. So what here would be remaining? 1. Agree? 1 lakh is out. So I would be having 1. 1 plus. Here what would I be having? 1 into. What is 1 into 10% into 3 years. Agree? So let's simplify it further. So what is 1,30,000? Future value. Agree? What is 1 lakh? Present value. Yes. 1 plus. Here simply there is 1, so we need not take into consideration. 1 plus R into N. Agree? Agree everyone? So if we take this example only, I had which present value of 1 lakhs. 1 plus R is 10%. We will take it as 0.1. 0.1 into 3. So what will be happening? 0.1 into 3. So 0.3. 0.3 plus 1, which would amount to 1.3. So 1 lakhs into 1.3, which will lead to our future value 1,30,000. So in the case of compound interest, so we had future value 1,33,100, present value 1 lakhs. R and N are the same. So in this case, we can say that how did I exactly arrive at 1,33,100? So future value is 1,33,100, which is nothing but present value. Yes, in this 1 lakh I got interest. That is nothing but 1 lakh into how much interest I got at the rate of 10%. Agree? Yes. For how many years? That is 1, 2 or 3 years. In the case of compounding, in simple interest we put it 3 over here. That is nothing but N. Yes. While compounding, we will be basically putting it over here, upper 1 year or 2 years or 3 years. So basically today I had 1. On that I would have got 10% interest, 1.1. Next year on 1.1 I would be getting again 10%, 1.21. Next again 10%, 1.331. Okay. So again 1,33,100. Same 1 lakh I will be taking it as common. So what I would be getting? 1 plus 1 into 10% whole power 1 or 2 or 3 years. So 1,33,000 is nothing but our future value equal to present value into 1 plus R, Greek, whole power N. Okay. So let's take what is the present value? 1 lakhs. What is the amount of rate? 1 plus R is nothing but 10, that is 0.1 whole power 3 years. So for period of 3 years. So 1 plus 0.1, which would amount to 1.1. Agree? 1.1, yes, into equal to how much would amount to 2 years. Okay, so 1.1 into 1.1 into 1.1. So 1.331. So 1 lakhs into 1.331, which will amount to 1,33,100. That is nothing but our future value. Okay. Next. Next, what we are going to learn. Okay. Next, we will be going to learn about present value of cash inflows and present value of cash outflows. Okay. So cash inflow. Okay. So cash in. So basically, I am receiving cash. Yes, cash inflow is nothing but I am receiving cash or money. Receiving money. Yes. Cash outflow. Cash is going out. That is nothing but I am paying money. Agree? So in this case, in cash inflow, we are basically assuming that money is depreciating. Okay. So let's take one example. Let's assume I had cash outflow. Okay. So let's take simple example that cash outflow is nothing but rupees 1 lakhs. Okay. Cash inflow. Yes. For year 1, let's assume that for first year it is 30,000. For year 2, it is 25,000. For year 3, it is 50,000. Okay. Let's take R. Okay. Okay, in this case we will be assuming R as a discounting factor or a present value factor. Okay, let's take R equal to 10%. Okay, R is also known as discounting factor or present value factor. I will be teaching you about present value factor as well as present value annuity factor. Okay, R is 10%. Basically, number of years is 3. So we are required. So what we are calculating? We are literally calculating what is present value. Okay, so present value is nothing but present value of cash inflow minus present value of cash outflow. Okay, just remember this. In capital budgeting, we will be learning about net present value in detail. Net present value is nothing but present value. So what exactly is present value of cash inflow? Present value of cash inflow is nothing but if year 1 rupees 30,000, if I have not invested it anywhere, what will be its value after the end of year 3? Year 1 is nothing but end of year 1, year 2 is nothing but end of year 2, year 3 is nothing but end of year 3. So 30,000 I have at the end of year 1. What will be its value at the end of year 3? So let's take it as year 1, 2 and 3. What is the amount of cash flows? So 30,000, 25,000 and 50,000. Okay. Or we also say it as present value factor, discounting factor or cut-off rate. Along with that, in further lessons we will be also knowing about capitalization rate and many other terms. Okay. So R is nothing but present value factor at 10%. So what exactly is present value factor? Okay, what will be the value? Let's assume value is 1. I have 1 rupee. What will be its value after the end of year 1? So we are not taking it as 1 minus 10%. In FM, we will be generally assuming 1 divided by 1 plus that rate. So 1 divided by 1 plus 10%, that is nothing but 1.1. 1 divided by 1.1. So at the end of year 1, I will be having 0.909, that is nothing but 0.909 paise. Okay, in simple terms, if we are understanding, at the end of year 2, okay, 1 divided by 1.1. So at the end of year 1, I had 0.909. Again, if we divide it by 1.1, I will be arriving at 0.826. So how do we calculate it in a simpler way? So present value factor, that is nothing but 1 divided by 1.10. So first year I got 0.909. Okay, yes. If we directly click equal to, I will also get it for second year, equal to 0.826. Yes. At the end of 3 years, how much? Again equal to 0.751. Yes. If we total this is known as present value annuity factor. Yeah, present value annuity factor, we will be learning it in very detail in capital budgeting. If we total this, it is known as present value annuity factor. Okay, how will we be totaling it? 0.909 plus 0.826 plus 0.751. So answer would be 2.486. So how will we be using the calculator with regard to present value annuity factor? So how do we arrive at present value factor? 1 divided by 1.10, it is not equal to 0.909, equal to 0.826, equal to 0.751. I am rounding it up to 3 decimal points. Then we will be clicking GT. GT will amount to 2.486, which is nothing but the same value. Okay. Make sure that in your calculator you should be having GT, that is nothing but grand total, not go to. GT we should be having, along with that we should be having M plus, M minus and MRC. Okay, and square root. Okay, make sure you have square root, percentage symbol, cross, that is nothing but multiplication, division, add, minus, equal to, along with all the digits 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then whatever the value, that is how do we on it, that is AC, this button. Okay, this much we should have. So what is its present value? First year 0.909 present value factor. Second year it is 0.826. At the end of third year it is 0.751. So what is its present value? That is nothing but PV. That is nothing but cash inflow into present value factor. Okay, so A into B. So 30,000 into 0.909, which will amount to 27,270. 25,000 into 0.826, 20,650. Yes, 50,000 into 0.751, which will amount to 37,550. This total is known as present value of cash inflow. 27,270 plus 20,650 plus 37,550. Total would amount to 85,470. Okay. So what is the simpler technique? So what we did, 30,000 into 0.09, we got this. 25,000 into 0.826, we got 20,650. 50,000 into 0.751, I got 37,550. Then we added it. So what is the simplest? So let's just take in the calculator. Yes. So we need to make sure that our calculator is good. We should know all the tricks when you are handling financial management. So how do we do it in calculator? That is nothing but 30,000 into 0.909. Click M plus. Yes, 30,000 into 0.909 M plus 27,270. Don't touch anything else. Next, 25,000 into 0.826. Again M plus 25,000 into 0.826 M plus. We will be getting 20,650. Next, 50,000 into 0.751 M plus. 50,000 into 0.751 M plus. Okay. Then after this, click MRC. So in the calculator we should be showing this figure 37,550 MRC. So 85,470. Okay, this is nothing but our present value of cash inflow. Here we will be getting total as 85,470. Yes, this is known as present value of cash inflow. Present value of cash inflow minus present value of cash outflow. Cash outflow is nothing but 1 lakh. 1 lakh is today. If at the end of year 1, I am assuming that 1 divided by 1.10. Okay. Here what did I calculate is nothing but 1 divided by 1.10. 1 divided by 1.10 equal to, here 1 divided by 1.10 equal to 1 divided by 1.10 equal to. Okay. So all these three and GT, if you press, we will be getting present value annuity factor. Yes. What is the present value of cash outflow? Cash outflow is nothing but we have got as 1 lakh. What is this present value? Cash outflow is nothing but amount that I am spending today. What will be my rate today? 1 rupee only. Yes. First year today. At the end of 1 year, meaning 1 divided by 1.10, that is nothing but 0.909. If it is today, then it is 1 lakh into 1. We are assuming it as 1. 1 is nothing but present value factor. For year 0. Year 0 is nothing but today. So present value of cash outflow is nothing but negative 1 lakh. So we are literally minusing it. Yes, minus. So 85,470 minus 1 lakh. So we will be getting it as negative 14,530. Okay, negative comes very rarely. Okay, only since it is an example, we have got it as negative. Okay, 14,530. This is known as present value of cash inflows and present value of cash outflows. Simple. Along with this, we will be doing some simple sums with regard to this. In detail, we will be learning net present value, which is nothing but the same in capital budgeting. Yes. Next. Next, we will be learning about compounding along with durations. Okay, compounding is nothing but compounding with regard to rates. Compounding along with durations. Yes. let's take simple examples. Okay. So let's assume R equal to examples. In example number 1, let's assume R equal to 12%. Yes, compounding is nothing but whatever the amount of rate is. Okay, R equal to 12% compounded annually. Yes, agree. So what will be the future value? Future value is nothing but how we will be calculating present value into 1 plus R whole power n. Let's take it, n is equal to 1 year only, compounded annually only for period of 1 year. So only with regard to R, what we will be doing? 1 plus 12%, that is nothing but 0.12 whole power 1, that is nothing but 1.12. Agree? Okay, let's take second one. R equal to 12% compounded semi-annually. With regard to this, there is some sums which might come. Okay, what will be the value of R? Let's take simple. R 1 plus R whole power n. Okay, what if we do it annually? Annual is nothing but 1 plus 0.12. Agree? Everyone. Whole power 1. Semi-annual is nothing for period of 6 months. So 6 months, 6 divided by 12, which would amount to 1 by 2. So here it is divided by 2, here into 2. Okay, make sure you are dividing it by 2 and multiplying it by 2. Okay, so 1 plus 0.06 whole power 2. So we are getting 6% interest once for 6 months and another time for again 6 months. So 1.06 whole power 2. Agree? Third, R equal to 12% compounded quarterly. So 1 plus R whole power n. First directly do annually. That is nothing but 1 plus 0.12 whole power 1. Quarter is nothing but 4 quarters. So here it is divided by 4, here it is multiplying by 4. So 0.12 divided by 4 plus 1. So 1.03 whole power 4. Agree? Next, R equal to, fourth example, R equal to 12% compounded monthly. Yes, we are done with annually, semi-annually, quarterly. Now it is monthly. So how will be calculating? That is nothing but 1 plus R whole power n. So 1 plus 0.12. First directly assume it as annually. 1 plus 0.12 whole power 1. Monthly is nothing but divided by 12. Here it is into 12. So 1 plus 0.01 whole power 12. So 1.01 whole power 12. Any doubts? Okay, next. Fifth. Okay, let's take R equal to 12% compounded for 18 months, compounded monthly for 18 months. Okay, so what is value of R? 1 plus R whole power n. Agree? 1 plus 0.12. Yes, for a period of, what we are assuming, 1 year. So 18 months. So we are doing it as 18. Agree? So 18 months is nothing but 1.5 years. So 18 divided by 12 we are assuming. Agree? 18 divided by 12, 1.5 years. So monthly divided by 12 here into 12. So 1 plus 0.01 whole power 18. So 1.01 whole power 18. Okay. So here what will be its value if we generally take? So 1.06 into 1.06. This is the normal calculation what we do. That is 1.1236. That is I am getting. Yeah. With regard to calculator, we can use it as 1.06 into equal to. If we assume 1.1236. So what did I do? 1.06 into equal to. it is automatically assuming that I am doing 1.06 into 2, that is nothing but 2 times 1.06 whole square. So 1.1236 is nothing but the compounding factor. What if I do into 2? This value 1.2625, this is nothing but for a period of 4 times. So into 2 into equal to, if I do 2 times, again if I do into equal to, it will be 4 times. So 1 divided by 1.06 into equal to 2 times, into equal to 4 times, into equal to 4 into 2 8, into equal to 8 into 2 16, into equal to 32, into equal to 64, into equal to 128. Okay, so this is simple example. 1.06 into equal to, so 1.1236. Yes, if we are compounding it at quarterly, 1.03 whole power 4, so 1.03 into equal to into equal to, so 1.1255, 1.1255. Yes, next 1.01 whole power 12, so 1.01 into equal to 2 times, into equal to 4 times, into equal to 8 times. So how many times I wanted? 12 times. So if I do into equal to again, it will be 16 times. So here we have to do manually. So 1.01 into equal to 2 times, into equal to 4 times, into equal to 8 times, into 1.01 into 1.01, so 10 times, 11 times, 12 times. So 1.1268, 1.1268. So here again 1.01 into equal to 2 times, into equal to 4 times, into equal to 8 times, into equal to 16 times, into 1.01 into 1.01, which will be amounting to 1.1961, 1.1961. Yes, this is simple examples, these are. Okay, with regard to compounding. Okay, next. Okay, so we basically know how to calculate future value and how to calculate present value. Okay, so how will be exactly calculating R? We don't know how to calculate R if R is not there. Okay, let's assume one simple example. Okay, let's assume one simple example where I will be using future value. Let's assume rupees 1,25,000. Yes. Present value, let's assume I am taking it as 80,000. Yes. Let's take n. Basically n equal to 5 years. I am required to calculate what is the value of R. So if the question is silent, we are assuming it as a compound interest. So how do we calculate with regard to compound interest? Future value is equal to present value into 1 plus R whole power n. What is the future value? 1,25,000 is equal to present value 80,000. Yes, into 1 plus R whole power 5. So 1,25,000 divided by 80,000 equal to 1 plus R whole power 5. 1,25,000 divided by 80,000. So 1.5625 equal to 1 plus R whole power 5. So let's take 5 over here. So it would be 5th square root of 1.5625 equal to 1 plus R. So you are required to calculate R. So how will we calculating R? Here we will be using concept known as dirty power. Okay, what exactly is dirty power and how to calculate it? Dirty power is used while calculating rate of interest. So how will we calculate this 1.5625? So first make sure that you write you calculate 1.5625. Agree? 1.5625 square root 12 times. Yes, only square root 12 times. Don't touch anything else. So 1.5625. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1.0001 that I am getting. Yes, square root 12 times. So 1.0010896 we are getting something. Make sure it is this one. So minus 1, second step, step 1 is step 2. So minus 1, make sure in your calculator it is 1 only, it should be showing 1. Okay, step 3, 1 divided by power, power is nothing but n, so in this question is 5, 1 divided by power, so 1 divided by 5 in this question, so into 1 divided by 5, you need not press into, you can directly do it as divided by 5. Okay, next step 4, plus 1. Okay, 1 divided by 5, so in your calculator it should be showing as 5 right now, plus 1. Yes, so now it should be showing it as 1. Step 5, into equal to 12 times. Yes, so it is showing it as 1 into, if you press into only, now it will be showing 1.4 times 0, 2179254 into equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I will be getting a rate as 1.0934, 1.0933. So 1.0933. Okay, which is nothing but 1 plus r. So 1 is coming this side, 1.0933 minus 1 equal to r. So 0.933 is equal to r, or r equal to 9.33%. Okay, 0.0933. Yeah, so 0.0933 into 100, so 9.33%. This is very important. The same we will be using it with regard to modified internal rate of return in capital budgeting. So make sure your dirty power is strong. Yes. So this concept is known as dirty power. Okay. So dirty power is usually used when we are calculating R value and nothing else. So what we learned? We learned about future value, we learned about present value, we learned about simple interest and compound interest. How do we calculate interest? Interest is nothing but future value minus present value. Okay. We learned about present value of cash inflows and present value of cash outflow. How do we calculate present value factor? Present value factor is nothing but 1 divided by 1 plus what is the amount of rate. Present value factor is nothing but R. We also use it as present value factor or a discounting factor, capitalization rate, cut-off rate, cost of capital, everything. Every term would be given. That is nothing but our R. Okay, present value factor. How do we calculate? For example, 1 divided by, if the rate is 10%, 1 divided by 1.10 equal to first year present value factor 0.909. Again, if we press equal to 0.826, we get, this is second year factor, is equal to, again equal to 0.751. This is third year factor. Again, if we press equal to 0.680 is the fourth year factor. If we again press equal to, we will get 0.621. That is nothing but a fifth year factor. All this after doing 1 divided by 1.10 equal to 5 times. And if we press GT, we will be getting it as present value annuity factor. Present value factor and present value annuity factor. How do we calculate present value? Present value is nothing but present value of cash inflows minus present value of cash outflow. Cash outflow as of now will be given in question only. Next we learned dirty power. Dirty power will be used when you will be calculating with regard to R, if R is not given in the question. Okay, dirty power, how will we be calculating it? That is nothing but square root 12 times minus 1 into 1 divided by power. Okay, power is nothing but what is the value of n? N is nothing but it will be stating it as number of years, 1 year, 2 years, 3 years, 4 years or 5 years as mentioned in the question. So square root 12 times minus 1 into 1 divided by power plus 1 into equal to 12 times. So we will be arriving at a value. Okay, so whatever the value is equal to 1 plus r as shown in the example. We put 1 this side, so basically value will be 0 point something equal to r into 100. We will be getting it as percentage. Okay, Okay, so this is all with regard to this video. In next video, we will be doing some of the simple sums with regard to time value of money. Only that much is enough with regard to time value of money, with regard from exam point of view, and nothing else. We need not do. There might be a lot of some spending from my side with regard to time value of money. You need not worry with regard to it. So same whatever pending is left, we will be learning it in an advanced level in capital budgeting as well as in dividend decisions along with working capital management. That's all for today. Yes, thank you.